So recording started, then officially hi and welcome to our embedded special interest group meeting on December 10th between Europe and Asia. And yeah, is there anything specific you want to talk about today, or shall we look at the shared memory proposal together?
I think we can look at the shared memory proposal.
1 second.
I'm sorry I did not look at it earlier. You did put a link into Zelig, but it was, I did not look at that until right before this meeting. So I was just taking a brief look at that and the sample code that you put in.
Yeah. In your defense, I just wrote in the Zulip that I wanted to put a link in, but I didn't put the link in. And I just put the link in 2 minutes before the meeting. So you're excused.
So I guess I was looking 1 minute before the meeting.
I gave you an easy out. So we can go over it together and see if it's in this round hits the right notes, or maybe you raise some awareness and we don't need to spend the whole hour on it. So let me quickly, I have it opened here. I put it on a new window, and then I'm going to share the window. Share. So you should see my screen now.
Yes, I can see it.
Okay. Make it a little bit bigger. Yes. So quickly going over it. So we are here, but also in discussion with others. See the need that we need some, let's say, high performance measure to share data between WebAssembly modules and WebAssembly modules and the host system, so the runtime. And we feel right now, or we think right now, that the methods offered by the component model, which includes, in a nutshell, lifting and lowering and a lot of copying of data from canonical ABI and to it. And so it seems to be resource expensive and might put a hit on performance. And so the general idea of this discussion, or the motivation of this discussion, which gladly Chris summarized a little bit. It's actually a summary of a lot of ongoing streams, and Christoph already answered to it because he's looking at different things. But the idea would be to have some kind of shared memory where, let's say, as an extension of the component model, or maybe a bypass of the component model. This is something we need to figure out as a group, to share memory between modules and between modules in the runtime. Did this help you a little bit? Or
Yeah, thanks for that. So I only, similar to Ron, I only look at this proposal now. And I skimmed through that, and my initial thought was that I see a mention of component model. Ideally, I prefer not to couple the proposal with component model, because I presume there will be use cases where people don't want to use component model. They want to use core modules and still leverage the memory sharing. That's why the option, I'm not sure which one is that mentions component model and modeling it for this environment doesn't seem viable to me, although I have to admit I didn't read it properly.
this one you mean, or?
Yeah.
Yeah. So I would say this goes in a similar direction, that if we tie it to the component model, and then we would not be able to use it outside of the component model. In the end, as component model in now version, is version 3 now released, 03, or I don't know. It seems to be there, so so the least we should achieve is whatever we figure out here should be interoperable with the component model at least. So people using the component model should also be able to use the shared memory, whether it's inside or outside of the component model, which I don't know of as of today.
Yeah, I agree. We should keep that in mind, but it shouldn't be a building block or the foundation of this proposal, I think.
Yeah. Thanks for your input. Okay. Quickly skimming over the document, is there something maybe a big question? Has somebody a seventh or eighth option in mind already? Or
so one thing, I'm not sure how much related it is to the discussion, but I know that a lot of use cases rely on the sandboxing environment. But there are use cases, like for example, my use case, where a sandboxing is not that important because we control the WASM code and we know it's secure, and it's for us having an option to disable sandboxing and just open up the entire address space to WASM is exactly what we need. And I know it breaks the fundamental assumption of WebAssembly, but maybe this should be something that we consider as well. As I said, I don't understand that this proposal is not exactly that, because it assumes that we still want to keep the sandbox environment. So maybe there's a different discussion, but I think we should have an option to just allow to access any address from WebAssembly.
Yeah. I feel you here, and this is something which really, let's say, keeps me up at night, that there are use cases where I would say, okay, if I just break open the sandbox, things would work, like you said. But then again, when I talk to our business owners, one of the main argument is the sandbox. So let's say as you said, it's a core fundamental thing. And I haven't come to a conclusion even in my inner dialogue so far. So
yeah. No, I totally understand. And I do agree there are use cases where the sandboxing is very important, but there are use cases where WebAssembly is primarily used as a portable binary instruction format, and that is us.
Yeah.
And we don't want sandboxing, or we don't need it. But yeah, as I said, not sure how related it is to this discussion.
Yeah.
Maybe we should have a different discussion about this, and maybe have it as an option in WebAssembly overall.
Yeah. So would you then actually look? So from what I heard, so shared memory alone would not be sufficient in your case.
No, it will be sufficient, because that means that everything in our application will have to. I mean, one option is to WebAssembly to just take over the entire memory, and whatever allocations we do in our application goes through the WebAssembly. But we don't want to do this, because we have a lot of systems in the application. Also, calling WebAssembly function every time we want to allocate or deallocate memory also feels a bit expensive in terms of performance. So yeah, we'd rather not to do that. We also have a couple different runtimes, not only WebAssembly runtime, we also have a JavaScript runtime. So all of those would have to have a replaced allocator to use the WebAssembly one. So it would just complicate our implementation a lot. So it would be possible for sure, but it would complicate the implementation, and also it might affect performance to some extent. That is why, we prefer to just open up the entire address space to WebAssembly and just be able to pass a pointer to the WebAssembly code, and the pointer can be then accessed from WebAssembly. That requires, obviously, for 32-bit platforms is fine, but for 64-bit platforms, like for example Xbox, we do need a build of WebAssembly 64 or the Memory 64 proposal.
So if I got it right, then mmap wouldn't be sufficient. Just doing some memory mapping into it.
We'll have to map, because we don't know in advance where the pointer was allocated. So imagine we have a JavaScript and WebAssembly, and they both do the same different things, or we have a Lua runtime or whatever. And we want to, for example, the buffer that is allocated by Lua, we want it to be accessible in WebAssembly. So before we pass a pointer to WebAssembly from Lua, we would have to somehow map the memory in WebAssembly first. Yeah, I mean, it is possible, probably. All I'm saying is that it overcomplicates the solution that we're trying to build. So.
And M mapping, just pre-M mapping, the bunch of memory that is needed to do all those, exchange is also not a viable option.
We'll have to mmap the entire address space, because we don't know where the other allocator allocates the memory.
That's what I mean. So if you open up everything, then why not mapping everything?
Yeah, I'll have to look at the second option, or the first option, and maybe as a viable. Yeah, as I said, I didn't have a lot of time to read the proposal. So
okay.
I also have I'm not sure about the multi-memory. I only briefly look at the proposal, but what concerned me the most was a sort of a toolchain support for that, because I think you need to compile time, at least with the current implementation of LLVM, I think you need to specify the memory index at compile time, which probably might not be viable for some of the approaches, I guess.
Yeah, with the multi-memory, there are some basic things that are still missing, right? So we implemented something in a WAT directly, not compiling anything, something like a get and set, where you have to hand over an index, and then you can use it, right? Then the user could compile to it, and the set and get is just exposed via WAMR. That's easy, and you have multi-module in place where you just load or kind of side load the WAT file also into it dynamically. This is basically possible, right? It's option 2. But yeah, it's assumed to be not very performant because with every access, first the user needs to know the index, which has to be written down somewhere, right? Or by convention. And second, you have a call, right? It's a function call that is not easily inlineable, so you will get a performance hit for every access, for every read and for every write. And this is basically not what we want.
Yeah, for sure not.
There's a raised hand. Please just speak up. No need to be polite.
Oh, I'll try to retain my politeness as best I can.
Yeah.
So, very interesting conversation, but I just wonder a couple of things. One of them is the are we talking about the embedded use case with the Amazon use case that was just described? Because that doesn't really sound like the definitions that this particular SIG have sort of agreed upon about what embedded means. I was not a participant of those particular conversations.
Yeah.
I just sort of agreed with them. You know, I think Stephen could weigh in better on that just because that was sort of the definition that I've been trying to follow versus other things that are interesting in WebAssembly, certainly, but not necessarily related to the specific embedded use case. Like I'm trying to understand the embedded device that you're running a WebAssembly runtime and a JavaScript runtime and the Lua runtime. I don't actually know what that device is. I don't think it exists. I think it's outside this, it's some kind of embedded Linux, but it's not a microcontroller like the things that this particular SIG is related to, although I could be wrong. Many times are. So, not to derail the conversation, but I just wondered if perhaps this is an interesting conversation outside of the scope of embedded, but maybe that's not specific to what we're talking about here. I don't know the answer though. Anyway, back on mute.
Yeah, let me just address that. So, yeah, we've been participating from the very beginning in those conversations and very upfront about the platforms that we support. I do agree it's not the typical microcontroller. Those are living room devices with a wide range of configurations. Definitely not microcontrollers though. My impression was that it still falls into this embedded environment. I think it's a broad term, so you can define it as you want. But yeah, let me know if you feel like this shouldn't be included. Then yeah, I guess we find
the only
another
other
place to
thing I
discuss
was
this.
wondering from your conversation is I don't know what I'm talking about here, but it just made me wonder, what you're describing is called compiling and linking. And I believe that problem's been solved. And if you already, I want to run it in a WebAssembly runtime that's customized to have allocation of large blocks of memory, or for that matter, all of the memory, that sounds like it's a problem that's a lot easier to solve than within this conversation, which is more about shared memory within the sandbox environment, I think. Anyway, back on mute, because I think Thomas has got something to say here.
I totally understand the connection to what is an embedded device. From my point of view, it's not only about the memory or the processor architecture. To me, it's also about what you're going to use, what you have to use, what you need on in terms of capabilities, updatability of your device, for example. This is not only the question: can I use a Docker container to put it on anything, right? It might work on an Xbox, maybe, I don't know. I'm not in this topic. It definitely will not work on very constrained devices where just the memory is not enough. In any case, the use case there is being able to update the device once it's rolled out over many years, and you want to reduce your effort in updating those devices and maintaining the software for heterogeneous devices. So this is basically what, for me, WebAssembly is one of the key aspects that can deliver it. And the difference of other use cases when we're looking at CDNs, cloud native providers, etc., is that these devices are usually everywhere. So it's not only the Xbox, it's maybe an NVIDIA Shield, it's maybe not only the browsers, it's the light switches in your room, it's the controllers in the train, right? Everything runs with software just everywhere. And these devices can be very capable in terms of compute power and memory. But that does not mean that they are quite near to quite as near to easy updatable than cloud systems that run a huge Kubernetes clusters, etc. Right? So this is very different. This is where WebAssembly kicks in, and the idea of having going away from monolithic software architectures to more don't want to call it microservice, but more decentralized software architecture. Also in these kind of systems, like in buildings, etc. Or as said, in trains, infrastructure, smart grid, you name it. Something that has the promise that WebAssembly might give us is very appealing. And yes, if you have decentralized software, maybe those software runs on the very same device, and they have to interact with each other, and they have to interact quite performant with each other because they're interacting with a real system, right? Like a cyber physical system. With a motor, with a drive, whatever. If this fails, then everything crashes. So you need to have some timings, made right. And that's what I think that the Sig-Embedded is also about, to talk about how can we make WebAssembly very appealing for these kind of use cases. And porting something to Xbox is just one case for it. And now I'm going to mute.
Yeah. And there's another race 10. So today we are super polite.
So since I was named, I'll chime in. I think there's a couple of things that work, and we went back and forth when defining what is an embedded device, and sort of the class of device that Marcin is talking about kind of kept going in and out of definition. But I think if you look at it from an embedded perspective, right, that doesn't mean it's low resources, although embedded systems often are. But this is a fixed function device, right? It's not a general purpose computing device. And so from that sort of definition of embedded, this fits, right? And I agree with what was just said. There's devices that have these capabilities that might be considered, not traditional embedded, but they're specific use cases. I'm assuming there's a lot of graphics acceleration and video decoding and whatnot that's provided in hardware, which is high performance. On the other side, if you look, this proposal, from what I understand, is part of standard WebAssembly. So I think the important thing here is we're not trying to make anything special or specific to embedded. What we're trying to do is influence the standard so that it works just as well for this class of device. And so what we're trying to do is not make embedded an exception. Although this group, obviously our motivations for some of these features are different than general WebAssembly, but this group is about, hey, what is needed in the spec to take care of the needs of embedded, and then how do we work that into the spec so it works for everything, right? And so while Marcin might be on the cusp of in embedded, maybe not embedded, the matter is this is something that's needed, and we're using the embedded SIG as a way to voice that, but we're really trying to influence the main WebAssembly standard and photo model and all other stuff so that these things work for our class devices. So anyway, that's just my 2 cents.
Yeah. Thanks for chiming in. Yeah. So there's a, I would say there's an lower and upper limit or boundary for what we call embedded, and there's certainly a gray area. Yeah, but and Stephen, thanks for bringing it to the actual point that yes, we are looking at our embedded needs or special needs in this case, and but also in this particular proposal here, we are also looking on let's say extending the WebAssembly standard then to be used outside of the embedded context as well. So maybe there are, I don't know, video streaming, data streaming cases where it could come in handy if we share memory. Maybe it makes sense to share memory between a CPU and GPU, but this would use different mechanisms maybe for machine learning use cases or whatever. So it's a little bit extending our scope there, but okay. So far, so clear. I've seen Christoph chimed in, and you obviously read the proposal because you gave an answer to it. So maybe Don't know if you want to elaborate here a little bit on this.
I don't know perfectly whether my audio works, so hopefully.
I hear you.
Sorry, can you hear me?
I hear you.
We can hear you clearly.
Oh, that's perfect. Basically, the idea was to create a memory semantic, memory attached semantic, which can be used for a future generation of a component model as well. So basically combining a way of just attaching memory with a logic of making sure that it's either read by many or read by a single consumer, XOR write attach. And yeah, basically I talked to Luke about this and it seems to match up with the semantics. Yeah, and I hope that this can really unify the different ones, because the lower or the lowest level of that one should just match fine with all the different things, including your GPIO example, which you shared. And I just have a link to that one. That one is programmed in Rust, and it's using Wasm-Time as a runtime, and it's basically attaching a shared memory multiple times to a sub-function, and then reading it out from the main function. And these functions are in different environments. So basically, they don't, apart from the memory which is shared using the host, they don't share memory. So it's a shared nothing component.
So, Christoph, I was looking at your code earlier. Thank you very much for working on that with actual code. I really appreciate that. I wanted to ask you, which one of these options do you think that maps to?
So wait, which one of these options?
Yes, what the code sample that you put in, which one of these options or options do you think that maps to?
Well, basically, the blocking part, which adds the basically, which adds waiting on the writer side for the reader to have finished reading the shared memory, so consuming it, and on the reader side for the writer part to have finished writing into it. This is a part I consider optional. This is probably not that interesting for your embedded setup, but this is what makes it very interesting to actually go for a streaming of frames approach, which is exactly what Luke was looking for.
Thanks for that info, but maybe I needed to phrase my question better. In the proposal for the memory sharing discussion, there's several solutions that are proposed. Option 1 being exposing an mmap, option 2. Which one of those do you think that your code sample matches, or which ones of them do you think?
Okay, now I got the question. So this is basically a variation of the memmap, and it's the guest is providing storage for the host to map the memory into. And the guest will basically ask the host how much memory to allocate and then give to the host. And then the host will just need to do page allocation or page alignment and similar things. So it will for sure return a different address, but it will use that memory if possible. And if you go for an MMU less, so basically an MPU solution, then I think your only option is to just map it somewhere, which will probably not be within the contiguous linear memory area. So with an MMU, it's really nice because you can just map a single page a single shared page into the linear memory at the address which the guest has provided to you, so that the linear memory is still contiguous. But if you don't have an MMU, you have to, basically work around that by having non-contiguous linear memory, and then, it will be somewhere in there.
Thanks. Yeah, that's actually very interesting for a lot of the use cases I'm interested in right now about video streaming as well. So I'm not surprised that Luke also was interested in that.
Yeah, and the trick is basically to provide some pre-allocated memory which the guest chooses towards the host for doing the M mapping. And the idea is to really have an M map on demand. So basically the memory is only mapped into the process whenever it consumes it or writes into it, but never between that, so that it's really a fully sandbox environment. And you can basically still, the host can, if necessary, fall back to copying the data. Because the semantic of accessing the memory, either readable or writable, is clear.
So it seems it's an option. It's a mixture of option 1 and option 5. Am I right?
Oh, yeah, for sure it's not. So it feels right. That is an option of mixture 1 and so. Yes. It's basically, it's an M map. It's a specialized M map which is not as powerful as the original M map proposal, Plasm M map. And it's clearly tailored towards some publisher subscriber.
Yeah. The question is, it's based on the stream kind of access pattern.
Yep.
So if you have random accesses, so not a consecutive, let's say, sequence of memory addresses, but random accesses, then more work would be necessary in order to make this, functional working.
It would still work. You would just not use all of the capabilities of the shared memory proposal, because you would basically always publish the so attach the full shared memory, and then also just say that you consumed all of it, or basically just
Gotcha.
So the example I wrote is not really a streaming example. It's really only attaching it and then random accessing the memory. So it's more close to your use case, instead of the really streaming one, which would be an extension which I did not yet program.
Thanks.
Welcome. And I feel for the guest, providing the address of the memory to the host solves the problem of just, having to work around the linker, or having strange gaps in your memory, or really of the most difficult things. Also, the host is not required to do the allocation in the guest memory and all these things. So it's really, the provided memory is under the control of the guest, and just the usage of the memory is under control of the host.
So it seems that the one thing that is in question is it only is working right now with WASM time, which might be difficult to bring on some of the target devices. Don't know yet.
I would,
Yeah.
for now, it's only implemented for Wasentime. It would perfectly work with Bummer as well. I just did not implement it for Bummer because I considered Wasentime the more complex one. Also, using it from the component model, I considered the more complex one. It should be just apart from the fact that it's specified using the methods of the component model, it should work perfectly fine with Bummer as well.
Mm-hmm. Thanks for providing the proposal.
Welcome.
Just to chime in on that last point, because I think it's super important. Just because it uses WIT does not require use of the component model. It's just a convenient mechanism for specifying the host guest interface, but that does not require that the component model be implemented. Obviously, it does require that the host provide those functions, but that's a really key point and a very cool part of this particular proposal is it uses the language of the component model, but without requiring the component model. I think that's an important point. So +1 on that. I feel like Christoph wants to say something and this mic is finally not working. It was working so perfectly before.
Sorry, my audio situation is quite complicated right now, and I'm in a tunnel, so the connectivity might also be low. So I didn't get all of that. If that was a question, I didn't get all of it. Sorry.
It was a +1 in a verbal way.
Mm-hmm. Okay. So thanks for the discussion. Thanks for the exchange. And Christoph, again, thanks for providing things to touch. Always good to have some lines of code in between the discussions. And so the Wasm time limitation, I fully agree with Thomas, and we need to look on ways how this concept can be exported to other runtimes. But anywho, it's already a cool working model. Yeah. So one thing, and then this is in the subtext here, but this comes with data sharing, is that we then have a somehow timely coupling to other modules. So we will we might not lose determinism, but we might get some uncertainty in. So if we share data and we need to wait for buffers to be accessible, this might introduce one or another knob, which we need just to keep in mind when we go for deterministic execution of our applications, which might not be always necessary. It's depending on the use case. So if we, I don't know, hosting a web server or whatever, then I don't care about some knobs. But if we are going into physical interaction, so controlling things in the real world, then maybe waiting for buffers to be freed can change the behavior of the outside world. So we need to keep this in mind and somehow I don't know, maybe make it even visible or make people aware that when we use shared memory, that we get a hit on determinism. So, just another problem I'm introducing. Sorry, no solutions, just problems from my side. So.
Dominic, I have a question.
Yes.
On this specific item, since we spent the whole time talking on this, what are the next steps or the asks you have from us on this item?
Mhm.
Obviously, I think the idea is figure out and settle on one of these options.
Yeah.
Potentially test it out, propose another option. But is there a specific ask that you and potentially Chris? I know Chris opened this about how you'd like to see this move forward, or
maybe I can jump in
Yeah.
as I'm also in close contact to Chris. It's also about we were talking about what are the use cases, the particular use cases. I guess he named it with A to D, A, B, C, D. So where do you want to have the memory being shared? Is it between WebAssembly instances? Is it between hosted WebAssembly? Is it between the host in another process, and the WebAssembly module should also access it? So basically, what is from the ESIG, or in particular from all members of the WebAssembly community, if they're talking about shared memory, why do they talk about shared memory? What do they want to share? Between which instances do they want to share the memory? And then think about, okay, what would be a good solution for them to meet the requirements they have, also the non-functional requirements, for example. Name it sandboxing, name it performance, name it synchronization primitives, whatsoever, right? The post was to open up the discussion to the whole community, to get known to the different use cases and which solution could fit more or less at the best all or most of the use cases. I think that was the intention of this post, because there were some emails in the background that were going back and forth between Chris and Luke and Christoph, etc. And so this was to try to open up the discussion. And now, in particular, we are asked to think about the use cases and to discuss the approaches we think are most promising.
So perhaps just adding a comment to this issue saying, I want shared memory for some specific purpose, and saying and this is what that is, and that way it's adding, that could be one way to contribute.
Sorry, could you repeat? Maybe my connection broke.
Sure. Yeah. Sorry, I'm on satellite connection, so the comment was, it sounds like we could contribute just by making a comment on this GitHub issue with, for example, I could say, I want to share memory between the guest and the host for the specific purpose of doing processing on video frames. And that way it's not some abstract, I want everything for all purposes, because that's not helping the conversation move forward to anything tangible. I think that was one way, perhaps.
Yeah, it's about to foster the discussion in the community about it and make it more open. And maybe we could also concentrate on some specific use cases, maybe take one or two ones and then do some exercise on it, which proposal could do the job.
Yes, definitely. Thanks. Yeah. So maybe if you have a comment, just drop it in. Okay. So it's close to the end. Is there anything to add or any new topic to open which can be addressed in the remaining 8 minutes? Or
I just would say anyone who is interested in shared memory, please hop on to the discussion, basically on the issue or inside the talks we are doing.
Yeah.
In order to go forward.
Yeah. And I definitely and I like the proposal to like have more concrete use cases collected, and so go with this. Okay. If there, I don't think it makes sense to open a new topic. If you agree, I would first of all thank you all for the vivid discussion again, and we need to write it down and move the proposal one step forward. And yeah, thanks for participation. And I think it has not yet been cancelled, but the next meeting would be on Christmas Eve, which would have pretty low attendance. So I think it will be cancelled. So probably we see each other in the new year. And with this, I would say also happy holidays and good start in the next year. Looking forward to do some more stuff with you all and see you around.
Thanks, Dominic. Thanks,
Bye, guys.
everyone. Happy holidays.
Bye.
Bye. Take care. Bye-bye.